All right, so we're going to look at 2.4 zeros of polynomial functions, and this one takes a while. So the objective is that you'll be able to find real zeros of polynomial functions. So we have rational zeros. Okay, rational zeros. Remember, rational numbers are numbers that can be put into fraction form. So you could put it as a number over a number. Okay, now there are going to be those irrational numbers. We know pi, that's a special one. That's a special one. We have square root of 2 and square root of 3, right? All of those irrational numbers there. Square root of 5. So sometimes we're going to have zeros that are rational numbers and sometimes that are irrational numbers. Now, we can figure out what the rational zeros are by uh, looking at the constant, the last number of the polynomial, and the lead coefficient. All right. So we're going to look at that one soon. All right, and then we can figure out like the possible uh, rational zeros, and then there's going to be a lot. You're going to see. So what we're going to do is we're going to use uh, a, we're going to use a graphing calculator. Now, graphing calculators, they became so advanced that they actually tell us the zeros. So we can't really do much with that. We're going to assume they don't tell us, and then we're gonna estimate what it is. All right. So let's look at this one over here. All right, so here we're going to list all the possible rational zeros of each function and determine which, if any, are zeros. And you're going to see a lot. All right, let's get 6. Okay, I'll do 6, and then if you want to do, I want you to do 2. Try 2. Okay, that one's not too bad. All right, here's 6. Why am I doing 6? I don't know. All right, yeah, but try 2. Sounds a nice one. So what we want to do is we want to take our constant, let's put it up here, constant over the lead coefficient. All right, that's how we're going to find the possible, and we're going to put plus or minus. So it could be positive, could be negative. We don't know. All right, so we're going to put 64 over 18. And notice how I'm not using this negative 64. I'm going to make it positive or negative. It doesn't matter. It does matter, but it could be either one. All right. So watch how many possible rational zeros there are. You ready? Here we go. So first off, we're going to write down all the factors of 64 and all the factors of 18. Okay. So the factors of 64, I'm going to put 1, 2, 4, and 4 times, uh, and let's put 8, and We have 16, 4 times 16. So 8 times 8 is 64, 4 times 16 is 64, 2 times 32 is 64, and 1 times 64 is 64. Ooh! All right. Now this is our nice one. This is just the factors of the numerator. The reason why is because we're putting all of the ones underneath our numerators here, okay? And you're probably asking, why the ones? You'll see, okay? And that's not it. We got more. So now we're gonna keep on writing those. We have 1, 2, 4, 8, 16, 32, and 64. All right, now this time we're going to divide by another factor of 18. So what are the factors of 18? Factors of 18. Let's do 64 here. Actually, that's 64, 1, 2, 4, 8, 16, 32, and 64. Factors of 18 are going to give us 1 times 18, 2 times 9, 3 times 6, and that's it. All right, so we're going to divide each of these by each of these. Whoa. All right, so here you go. We're going to divide each of these by 2. So, so these are all divided by 1. Okay, so we're done with the 1. Let's cross that out. Now we're going to divide everything by 2. Divide by 2, 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 divide by 2. Now, sometimes this happens. 2 divided by 2 is 1. Wait a minute, we already have 1 right here, so we don't really need this one. And here, 4 divided by 2 is 2. So we don't need this one either, because we already have it here. Same with this one. 8 divided by 2 is 4. So we don't need that, because we already have it. 16 divided by 2 is 8. We got that already. 32 divided by 2 is 16. We have that already. 64 divided by 2 is 32. We got that already. So the only one that we had on that in that row is the 1/2. All right, that's the only new one. And do it again. So we did the 2's. Let's cross that out. 4 more to go. I was not lying about a long process. 1, 2, 4, 8, 16, 32, and 64. So the next one we're going to do is 3. So let's put 3 here. Divide by 3, 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 divide by 3. All right, does 3 go into any of those? No. 2 divided by 3, no. 4 divided by 3, no. 8 divided by 3, no. No, no, no. They're all even. So 3 doesn't go into any of them. All right. So we keep all of those. All right, and then we're going to do it again. We're done with the 3's. Now let's do the 6's. 1, 2, 4, 8, 16, 32, and 64. Here we go. Divide by 6, 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 divide by 6. All right. Now, because 6 is even, just like many of those on the numerator, most of those on the numerator, we can actually simplify this. So 2 divided by 6, so 2 goes into 6 3 times, so we get 1/3. So this becomes 1/3. Do we have 1/3 already? We do, so we don't need that one. 4 goes into 6, so what goes into both 4 and 6? 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. 2/3, we got it already. So since they're all even, just divide by 2. Divide by 2, we get 4 and 3. So 4/3, we have it already. Don't need another. 16 divided by 2 is 8. 6 divided by 2 is 3. And look at that. Looks like it's all going to repeat. Divide all those by 2, and we get all of them already. All right. And on to the next. So we did the 6. Now let's do the 9. 2 more. 2, 4, 8, 16, 32, 64. So divide by 9, 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 divide by 9. Now, since 3 didn't go into any of those, 9's not going to go into any of them because 9 is a multiple of 3. So it's pretty impossible. All right. So all of those stay. All right. And one more row. Yay. You got 18. 1, 2, 4, 8, 16, 32, and 64. So divide by 18, 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 divide by 18. And there, we have 18 is even. Most of those numerators are even as well. So divide by 2. You get 1/9. We got it already right here. So you don't need that. 2/9, we have that. 4/9, we have that. We're dividing everything by 2. So 8 divided by 9, we have that. 16 divided by 16/9, we got that. 32/9, we got that. All right, and there you go. So these are all the possible rational zeros that we have. Ta-da! Okay, so that's how you find the possible rational zeros. Now let me take a picture of this because I'm gonna erase something. So I have enough space to do anything else. Yeah, 2's not going to be too bad. So yeah, try 2. All right. And I'm going to erase these that I crossed out. So we're just focusing on these zeros. Okay. So what we're going to do, move everything up. Okay. So Now we're just gonna try each one. Oi, oi, oi. You're probably thinking, really? How many is that? This is 1, 2, 3, 4, 5, 6, 7, and times 3, 21, plus 3, 24, times 2, 48 possibilities. Whoa, what? All right. So I don't know who would want you to try all of them. We're gonna try one, and then we're gonna use the Desmos, okay? Save yourself some trouble. This is crazy. All right. All right, so we're gonna try our first one, which is, let's try positive one, okay? So positive one. And I'm gonna put all my coefficients. So we have 18, 12, 56, 48, and negative 64. Remember, those are the coefficients in our, right here, and our constant. All right. So I'm not going to color coordinate because it takes too long. So here, we're going to bring this down. 18, multiply. 18 times 1 is 18. Add. I'm going to get 30. Multiply, we get 30 times 1 is 30. Add, we get 86. Multiply, 86 times 1 is 86. Add, we get 134. Multiply, we get 134. Add, we get 0.7. All right, 70. And that's our remainder. So it's not 0, so not a 0. So we want it to equal 0. All right. Now let me show you how you can use the graphing calculator. Um, yeah, I'll put this away for now, and then I'll bring it back. Okay. So let's look at the Desmos. There we go. Use the graphic calculator. What was the problem? 6. So I'm going to write here y equals 18x and then a to the b, so 4. And then bring the cursor down. Plus 12x a to the b, 3, plus 56x squared plus 48x minus 64. All right. Now here they show us what it is. Okay. You zoom out, and that's about it. So they show us what the zeros are. All right. So what we're going to do is we're going to estimate. Okay. So here, notice that it's in this first one over here is in between -1 and -2. And it's closer to -1. So I'm going to say that's going to be -1.3. Okay, -1.3. So if we look at our zeros, bring those back. There you go. If we look at our zeros, -1 over -1.3, so it's going to be about right there, -4/3. Okay, -4/3. So I'm going to try to plug in -4/3, and I'm going to erase these right here. So try out -4/3. Do synthetic division. 18, 12, 56, 48, -64. Bring it down, multiply. 18 times -4/3. So 18 divided by 3 is 6 times -4 is -24. Add, you get -12, and multiply -12 times -4/3. So -12 divided by 3 is going to give us -4 times -4 is +16. Add, we get 72. Multiply 72 divided by 3 is going to give us 24 times -4 is going to give us -96. Add, we get -48. Multiply, -48 divided by 3 is going to give us -16. So 16 times -16 times -4 is going to give us +64. Dun, dun, dun. 0. So it's 0. So it's a 0. It's a solution. Okay. So -4/3 is one of the x's. Yay. We got 1. Looks like we have 2. So this other one is going to be right there. And that's close to 1. So it's going to be 0.7. All right, so 0.7. So it's not one of these. 1/2 is 0.5, so it's more than that. Definitely more than this. Okay, because that's really small. This is really, really small. So it's not those. 1/3 is 0.3. 2/3 is 0.66666. So it might be that one. All right, we're going to try that. And it's a positive. So it's going to try +2/3. So this is what we had to do. Use a graphing calculator and then check. What's the possible one? So 18, we can actually plug in these if you want. Make it less work. 18, I'll just put the original. 12, 56, 48, and -64. Bring it down, we get 18. Multiply, we get 6, 2 is 12, add 24. Divide by 3, we get 8 times 2 is 16. Add, we're going to get 72 again. And then multiply, we get -96. It's the same as the last one. Add, we get -48 again. And then multiply, we get 64. Add, is 0. 0, so it's a 0. All right, so x equals -4/3 and +2/3. There you go, and that's our answer. And I believe they wanted us to put it in factored form. Ah, okay. So because they want us to put it in factored form, let's use those new ones. Sorry, wasted time. All right. So we are going to use these right here, the new coefficients, because it should work out. Still going to give us 0. All right. So I bring this down, 18, multiply, we get negative, we get 12, add 0, 0, add 72, we get 72 divided by 3 is going to give us, oh, 24. Okay. Oh, and we get 48. I'm sorry. Yeah. And there we get 0, 0. So it's a 0. All right. So there we have 18x squared plus 0x plus 72. We know this is always going to be the constant, and then x squared term. All right. So we don't need that 0x, so this is just 18x squared plus 72. You're probably thinking, what if there's another 0 there, Mr. T? We can't, because this is, if this was a minus sign, maybe it could be possible. All right, but it's a plus sign. And since this is a squared, that's it. If it was squared and a negative, we could probably factor another one. All right, but here we can't. So that's 1. And the other one is going to be here with this negative 4/3. So x, and then not minus 4/3, but plus 4/3. And then x, not positive, not plus 2/3, but minus 2/3. But you don't usually like to have those fractions, so just multiply times 3 times 3 times 3 times 3 to get rid of those decimal fractions. And you get 18x squared plus 72 times 3x plus 12. Sorry, what was I thinking? 3x plus 4 times 3x minus 2. And that's it. Our answer. All right, that is that. So try number 2. And if you want to check your work, you can. Yeah, just try that. Oh, negative 1.333 and 0.667. There you go. That's it. All right. So let's go back to the PowerPoint and then just try number 2. All right.